The interactive beam design allows you to examine and alter individual beam design in more detail. You can select the beam, then click on this icon. Alternatively, you can double-click on the beam axis. This will launch the beam interactive design. The header of the dialog is reinforcement data. Maximize it. Click on the Beams tab at the top. This dialog shows the constituent of the members and the related information, such as length, clear span and size. These are automatically extracted from the model. There is a 3D diagram below illustrating the beams in the design axis. The selected beam in the table will be highlighted. The side view and the 3D view icon simply changes the direction of the 3D view. In the beam table, you can edit the beam section. If you do this, the beam size will change in the main model. This will result in a change of loading and stiffness of the model. Hence, to get accurate design forces, you should rerun building analysis. Click Cancel. In the support table, the left, I, and right, J, support conditions are also automatically extracted from the model. Although you can change this, be very careful about changing it here, as it means the assumption is no longer consistent with the model you built. Select Beam GB1 and click Interactive Design. This will show the key design figures, such as the design moment and shear, and the required steel. The design forces are automatically determined from the envelope combinations of the analysis. If you wish to delink from the analysis and key in your own design forces, you can check Edit manually. Then you can overwrite all the design forces based on your decision. Click Cancel to exit without any changes. Click Rebars tab. At the very top, beams are drawn in 2D as continuous beams, including all span dimensions. There is a curve annotation on GB3 to mark it as a curve beam. The blue figures are required steel area based on the design moments envelope. The extra AS row shows the surplus steel area, based on the steel, that is automatically selected, shown in the rows below. The rebar rows shows the main bars which are automatically selected. The top bars are topmost span bars. At the end span, the top span bars extends to the top support, as we have chosen to extend top support bars to end support, in the curtailment settings. The support top bars are provided only over the support. The bottom bars controls the bottom span bars which can overlap into the bottom supports. The support bottom bars are confined only to the bottom support. Web bars are the side bars. To check and visualize the beam details, click Detail Drawings icon above. Close it. Next are the links or stir-ups. Click any links of GB1 to expose detail shear design information, such as the design shear, VD, and V maximum. Torsion is also checked and designed for. For beam GB1, the concrete torsional capacity is sufficient, so no additional torsional links are designed. Click on the links of GB3. For this curve beam, the torsional links are required and designed, as the torsion force is larger than the nominal capacity. Sidebars or web bar, AS/T is also added, as per code requirement. Click on any other cell to close the shear dialog. Next two bottom rows are AS minimum top and bottom. S bar stands for spacing of bars center to center. Deflection check shows the length divided by effective depth ratio checks. X support links. If 0 is shown, it means nominal links are sufficient for the entire beam. If left or right support shear is higher than nominal, the distance of the support region, where higher links must be provided, will be shown. Fundamentally, in this dialog, there shouldn't be any red figures, which will indicate failures. Let's try to trigger some failures for illustration. You can manually change or overwrite the rebars. Click on top bar of GB1. Decrease the bar number. Immediately, a red figure is shown in extra, a S row. The figure shown is the amount of deficit. This means the rebar is insufficient. Further, the bar spacing also fails, as shown in the S bar row. This is because the spacing between the bars is now more than the maximum spacing preset. Click to decrease the rebar diameter. Notice now more red figures appear. Now, even the minimum area of steel is not satisfied. Click Select Bars at the top to redesign the beams to the original. You can change the curtailment of the bar. Click on Same Top Bar. Under the steel bars group icons, you can see the left-hand curtailment is Extend Left to Lap, which means the bar will extend into the support of the column. Click on the drop-down menu, change to Extend Left to Short, which means the rebar will stop short of the column. Reduce the bar to 3 numbers of H10, and it is still sufficient as there are no red figures. Now click on left-hand support top bar cell. Set to 3H13 to satisfy the required steel area at this location. Click on Detail Drawing to inspect the change in the beam detailing. Close it. You can also change the bar layers. Click Top Support Bars here. Currently the design is 3H32 in a single top layer. Say, we would like to split to 2 different top layers instead. Change it to 3H25. Then click on the row immediately below, Support Top Bar 2. Set to 3H16. Notice the clear bar spacing fails. The reason is these bars are still placed in layer 1. Click Bars at layers 1 to change it to layer 2. The bar line will change to a dotted line, indicating it is in a different layer. The minimum bar spacing is also refreshed, and there is now no failure in this check. Click Detail Drawings to check the detail at this position. Close it. Click Select Bars at the top to redesign the beams to the original. Click Diagrams to view the design diagrams. By default, envelope is shown, which is the superimposition of all the load combination. You can click on any load case or load combination. Click L-2 to show the vertical frame loads calculated on the beams. Vertical deflection can be shown by checking the Delta 2 box. If you want to create a proper report, click Report and choose the desired option. OK. Close the report. Note this diagram is also accessible on the modeling view. By choosing a beam on the plan view, right-click, choose Analysis Result Diagram. Exit the diagrams. Click Display Moment Values. This dialog shows a summary of the design moments in 3 design zones, top and bottom. Shear force and torsion is also shown. The design forces are derived from the envelope diagrams. If you click Edit manually, you can overwrite these values. Click Cancel. By default, the length of the beams in the diagram is not drawn to scale, as shown by the icon, Not Scaled. Click on it again to change to scaled. Observe the difference. Previous span and next span are used to move focus of the rebars from span to span. Alternatively, simply use the scroll bar at the bottom. Span length is used to adjust the scale of the diagram. For example, if the texts are too close and it's difficult to read, increase the scale. Steel bars icons are used to change the bar's characteristic, such as curtailment, crank and layer, as demonstrated earlier. You can copy the bars of a beam and paste it to another beam. For example, select top span bar of GB3. Click Copy Bars. Select the top bar of GB2. Click Paste Bars. All the top, bottom bars, and side bars will be replaced. Design Report will print out the beam design report for this particular beam axis. Click Cancel to discard any changes and exit. Filter Axes. You can filter by story, member labels, and failed members only. This is very useful if you want to focus on certain elements only. If the model is very large, you may want to filter by stories to batch design beams progressively instead of all the beams in one go. Click Cancel to close without any filter. You can copy and paste bars easily to other beams. Select Axis B. Click Copy Bars. A green equal sign will appear next to the beam axes, having exactly the same beam span and sizes. This means that you can paste the rebars to these marked beams. You can paste individually by selecting a beam axis, say axis E, and then click Paste Bars. The rebars will be pasted, and the beams will automatically be checked if it passes or fails. The utilization ratio will be updated accordingly. You can also paste bars to all similar beam axes by clicking Paste Bars to All. However, we will not do this, since this will likely be insufficient for some beams. We have completed the beam design. You can close the beam section design menu.